Terry Wolfgram is going to be our first speaker, a tag team with Patrick Rennie. Terry is the only person I know that has flunked retirement 2 more times than I have. She has degrees from the University of Montana and Montana State University. Yay, go Bobcats. She worked seasonally for 10 years for the Museum of the Rockies. In 1996, she accepted an archaeological position with the Bureau of Land Management, and she worked there for 20 years, mostly on AML sites, abandoned mine lands. And she retired in 2016, first time. She is originally from Forsyth, born in Forsyth, and then went to Columbia Falls. So she's from the gateway to the Glacier National Park, but also the gateway to Colstrip. All right. So, and her co-presenter is Patrick Rennie. He is born in Wilsaw, Montana. He received Wilsaw, you guys probably haven't heard about that. It's just a small town north of Livingston, somewhere up in there. He received degrees from Montana State University and University of Montana. I don't know why they flipped them that way. He currently serves as archaeologist for the Montana Department of Natural Resources and Conservation, and he is a friend of my old college roommate who ended up marrying my wife and I. And he is very good at mentoring young archaeologists, and he works diligently trying to complete a lot of old archaeological data that has not ever been published. So he spends hundreds of time besides his normal job doing that. So Patrick, thank you for that. So without further ado, we're going to have them talk about the Three Waters Quarry and the Schmitt Chert site. Terry?
Thank you. So Patrick and I are talking about this because we both went to MSU, and this is where we worked every year while we were there. It was our field school. So the Three Waters Quarry and Schmitt Chert site of Dr. Davis came to MSU about 1969, and shortly after he came there, he was contacted by a man from Three Forks, Montana, about an archaeological site that he had discovered, and he was really excited about it, thought that Les should go up there and see it. And as it turned out, it was an incredible site. It is very unique in the United States in the fact that it is an underground chert mine, prehistoric underground chert mine. That's one of its unique characteristics. The second characteristic that's unique is that it was closed. It was totally backfilled and closed. And so probably the first mine closure in the United States, actually. It's pretty neat to think about it. So, see if I can get this right here. I'm not getting my thing up. Let me use this.
Okay. Just right click.
Or not.
Oh, because the mouse is now active.
Oh, okay.
Now
But it's not on the thing down here. Okay. So the Three Rivers Quarries and Schmitt Chert mine are located at the headwaters of the Missouri River. You see the Gallatin coming in here, the Madison here, the Jefferson here, and about it's north of Three Forks, maybe 5, 6, 7 miles. And right across the river they're still mining. This is the GCC cement plant at Trident, of course, mining all of the limestone there for cement. So Les went out there. This is a first look at what the site looked like. You have all these depressions, which are real common for surface collection of chert, something we see in the field all the time. What we didn't know at that time, what he didn't know at that time, was that that they went underground and were not just surface collections. An aerial view showed that here's where those were, but to the northeast, if you can see here, there are more. Here's a better, larger picture of them. This is again not showing up. So on the right, how do I get it? I don't know how to get it over there. But on the right slide, there are those depressions. They were all collared, actually, which indicates that there's probably another underground mine there. We just did not excavate it. So, excavations began in 1972. It took a while to get funding and make sure you got all the vehicles and the classes set up. For 17 years, they excavated this site, was our field school. For 17 years, everybody that came through, if you were an Archie major, you took Archaeology 101, and you learned how to do the archaeology out there, and the next year you took Archaeology 201, you were a supervisor, and the next year you took Independent Studies, and you were a supervisor, and the fourth year you were Independent Studies again, and you were a supervisor till you got through school. Spent a little time out at Schmitt. And it was a great experience. So this is early on when it was first beginning. There were, as you can see, quite a line of screens for screening material that came out. There was so much material that we had to use a bobcat, actually, to keep moving dirt back and forth. I'm going to go back a slide. Part of the site included 3 stone circles. Formerly, we called them teepee rings. And one of the first things that they did was to excavate those and mitigate them because we're going to be in and out of there with a lot of dirt and equipment, what have you. So the early stone circle excavation there, and then moved into more of mining the mine. Continuing excavations every year revealed that there was a north-south trend to their mining. They started at the south end and moved north, and then along the way they had several entry loci into the bedding plane, so then they were moving west into the bedding plane, and later detailed drawings of the mine with all of the stratigraphy and everything revealed that what they were probably doing was following decomposed limestone fissures that had loose cobbles of chert in them, so the chert wasn't so hard to get out. They still had to do a lot of rock work. They had to beat rocks. They had to remove rocks. They did remove some large chunks of rocks, and we don't know exactly how they levered them out of the mine because we never found any wood. Of course, by the time that we excavated there, it was 1,000 years or more later, so it probably decomposed. There is some evidence that they were able to move rocks up onto areas where they had already mined. So anyway, it was quite an excavation. They tended to move the dirt back into areas where they had mined before when they were moving from south to north. So the further north they got, they just dump it back in the southern exposures. They did put dirt underneath outcroppings. If they had gone underneath a limestone bed and it was fragile, they built it up and held it up. They did find a stope, actually was stoped in one area, and that room was filled nearly to the ceiling with backfill dirt, probably for the safety, because it got deep. For 17 years we went. Neither Patrick nor I were there right at the end, but the last time I was there, we were down 20 feet vertically and 30 feet into the bedding plane to retrieve the chert. These are some of the pictures at the late point when we were there in the mid to late 80s. It had collapsed. We finally had to start wearing hard hats which was, you would think would have it from the beginning, but we didn't. You know, I guess archaeologists think we're indispensable and invisible, but you can see how deep it was from the ladders, and on the left, there's a chute to haul buckets of dirt up. One of our goals was to find everything in place. Unfortunately, I mean, that's always the goal in archaeology, to find your artifacts and information in situ. But since the mine had all been backfilled, everything was secondary deposit. And it included everything. I mean, when you are backfilling an archaeological dig, for example, and you have to fill the whole, I mean, we throw in everything, cow pies, sagebrush, whatever we can. So they were filling in with a lot of debris from the campsite, and the campsite was just to the north on the plain downhill from the mine. And so we had a lot of things from the campsite that were obviously campsite tools, hide-working tools and things like that we found in the mine. So this happens to be upper left, a picture of some, I think it's a rib, obviously, that was found in place, but that's probably not where it was in the beginning. So Patrick's going to talk to you now about the tools and all the things that we recovered.
So the Schmitt site, what's really quite intriguing about this is we know pretty much when excavation work started there, and by excavation I'm talking to the original aboriginal work, and when it ended. It took place approximately 3,000 years ago and continued onward up to about 2,000 years ago. So roughly a period of about 1,000 years, this site was excavated, probably not continuously, probably not year after year, but certainly within short enough durations that the next generation wouldn't forget about where this location was and what the process was to mine. To the best of our knowledge, there's nothing else quite like this site complex in Montana. I think to date I have a record of approximately 80 or 90 chert sources, primary sources, where the chert material, toolstone quality chert material occurs in Montana. I don't know what the total number is out there. It's just what we have a record for. Oftentimes you see very small depressions that leave kind of a golf ball looking surface, pockmarked surface. The pits might go down 3 or 4 feet to recover chert just below surface, but an actual open trench mine like this is unprecedented in Montana. And also, the other problem with most of our chert sources is that they were used since people first discovered them, a lot of them. And so we can't sort out different occupation events. The neat part about Schmitt is, again, it was used by one specific group of people that we refer to as Pelican Lake, or the Pelican Lake culture. Some of the tools that were brought in to smash through the limestone are hammer stones and groove mauls. There are also a lot of antler tine tools that were brought in. There's speculation they were used in the mining process. I'm not convinced they weren't used as pressure flaking tools. As you'll see later, there's a tremendous amount of finished tools. We can learn a lot from the actual debitage that's left behind at these sites, but the problem with some of it is that the sediment wasn't, at least a sample, wasn't screened through fine mesh, so we could recover the really small pieces of debitage and know exactly how much on-site tool manufacture was taking place. There's at least 4, if not 5, grooved mauls that you can see here that were recovered from, I suspect, the mine. The problem is with the catalog sheets, it's not always clear what part of the site the artifact was recovered from. This open mine that you're looking at is only one part of the site. There's a campsite, as Terry mentioned, about a quarter mile off. There's another possible campsite down by the river. There's a couple other these mine or quarry sites, pits that have not been excavated. So we're just assuming that everything came out of the mine itself, the part that was excavated. When I talked about Pelican Lake, it's based on a style of projectile point that has fairly specific temporal parameters. For us in the Northwest Plains, the accepted date range is about 1900 radiocarbon years before present to as much as 3500 radiocarbon years before present. Now, the problem with this corner notch point, by corner notch point, I'm talking about the way, the angle that the notches are placed in these points. You'll see they're fairly sharp, and they're oriented at a 45-degree angle to the long axis of the piece. That's fairly characteristic of the point styles that are representative of Pelican Lake. Pelican Lake occurs throughout the northern plains, but depending where you're at in the northern plains, the terms change. You go south from here, everybody says late Archaic corner notch. You go to the Great Basin, it's called Elko corner notch. You go to the Midwest, you've got things like Wade points and Delhi points, which are also corner notch at the same time. The interesting thing is when these point styles change, they change rapidly and they change over massive geographic areas. In fact, the change is so quick, it's hard for us to actually get temporal control over. Is there overlap? Did they just change it once everywhere? So it can't be the same group of people. It's got to be multiple different groups of people, but somehow they accept the idea that at certain times the point styles change. This is the only point style that's been recovered at the Schmitt site. And what's interesting, as many as 64 points, projectile points, have been recovered from Schmitt to date. At least 35 of those I know came out of the mine. I have good records for that. So that's about 55% of the recovered points came out of the mine fill. When we talk about this chert, I'm assuming, I'm taking for granted everyone realizes that we're talking about something in archaeological terms. I'm talking about this cryptocrystalline silicate material that fractures conchoidally and is used to make stone tools out. It's quite glassy in appearance. I know for geologists, chert takes on a wider meaning at times, but for me, it's when I say chert, everything I'm talking about is something that's tool quality that can be formed through combination of percussion and pressure flaking, and that's how these tools were made. Other formal tools are what we call end scrapers. They were used to work hides, to deflesh hides. And 75 end scrapers have been recovered from Schmitt. There's other roughed out bifaces and bifacial preforms. By that I mean you take a raw piece of stone, you break off a piece that you can actually work with, and then you start removing flakes systematically from each sides to shape it. So oftentimes you'll hear people refer to these as spear points. That's not what they are. They're just roughed out preforms. You can make more flakes for cutting scraping tools by reducing these. You can make other formal tools out of them. So they're really quite durable and handy pre-tools, if you will. And I'm not sure the exact count of preforms that came out of the site. I'm sure my number is low. I think I only came up with about 5 from what's documented. This is a fairly specific stylized artifact called a tang knife. 3 of these have been recovered from Schmitt, and it shows the connection with Pelican Lake. So I wouldn't go as far as saying it's a diagnostic artifact for Pelican Lake, but it certainly was the kind of artifact that shows up frequently among Pelican Lake assemblages here. There's some imported items too, things that typically would not preserve in most of our sites in Montana because of the open air conditions. But because some of these were tucked in under the rock, under the bedrock, in an environment that was more conducive to preservation, they weren't acidic at all. Things like this olivella shell from the west coast, there was actually, it appeared to be, Terry was telling me, it appeared to be a remnants of a necklace that had broke and was abandoned in the mine or left behind or lost, whatever the case may have been. But this was imported through trade, obviously, from, like I said, the west coast. That's quite a distance. I guess before I get to that one, let's talk a little more about trade items. So there's obsidian. The two closest sources of obsidian to us that were frequently used is Obsidian Cliff in Yellowstone Park and Bear Gulch sources in southeast Idaho, south side of the Centennial Mountains. The neat part about obsidian and some other volcanic rocks we're finding is that it can be sourced. Once you know the trace element chemistries, each source has its own unique chemical fingerprint. 9 pieces of obsidian collected from Schmitt were subjected to sourcing analysis. 7 of the pieces are from Bear Gulch, Idaho. 2 of the pieces are from Obsidian Cliff. Most people think of obsidian, they think of Yellowstone Park. The fact is, in Montana, most imported obsidian actually came up the Missouri river drainage, actually came up from the Bear Gulch sources in Idaho. The Yellowstone River makes sense, is more dominated by materials out of Yellowstone Park, Obsidian Cliff, but the pattern of a dominance of Bear Gulch obsidian and Schmitt just follows suit with the Missouri River area. Other materials is called porcelainite. It's a tool stone that's formed in the coal. It's of coal burn origin. It's formed in Fort Union Formation. Happens when coal seams burn and it gets hot enough to the right temperature to bake the overlying stone into basically a porcelain. And southeast Montana is the closest known sources for porcelainite. Porcelainite was recovered from Schmitt. There's also a material called Knife River flint. I'm dubious whether it really is Knife River flint. A lot of our sources will produce material that's visually identical to Knife River flint here, but it's fairly distinctive brown glass looking material. And if that's the case, there's more evidence that this material is traded. Is that unique in Montana? No. Almost every site you find evidence for traded items or other imported materials. The neat thing about Schmitt is the preservation there, especially with the organic materials and the amount of organic preservation. That's what we don't have in most of our sites, but we do at Schmitt, so we have a lot more things like imported shell. Faunal remains that were brought into the site as well include a fair amount of bison bone, as you would expect. That seems to dominate most of the more open plain settings in Montana. But the antlers, dominated by white-tailed deer. There's a fair bit of elk antler that were cut off the beams and brought in, and only one elk mandible. Were they processing these animals at the site? That I'm not sure of. They may have just been using selected bones for mining purposes or for other domestic activities in the mine itself. And the big question is, will always be known as a Chert mine, but it is so different from any other Chert quarry, and mainly the lack of debitage. I went to the Museum of the Rockies where the materials are stored recently, and they only have 11 boxes of the waste material, the waste pieces. So when you're working a piece of stone down to make a tool, you generate a lot of waste. In fact, one cobble, I can generate 1,000 pieces, right? This is 11 boxes. I could go around to any Chert quarry around here and fill 11 boxes in under an hour with just the stuff on the surface. So the big question is, if Chert mining was the primary focus at Schmitt, where were they processing the raw nodules, or were they processing it? Or were they taking it to the river, floating it somewhere else? I mean, it'd be unusual because typically the processing takes place there, but Schmitt has many questions that we simply can't answer. There's a lot of speculation as to how the processes occurred, why it occurred. We simply don't know why the process began and ended when it did, or why no other groups picked up in other locations. But Schmitt truly is kind of a gem in Montana archaeology and has a lot of questions that it could be able to answer. Questions for Terry or I?
I wanted Patrick to tell you why Green Chert is better than just the surface collection.
Well, typically, and actually, I have not worked with so-called green chert dug out of the ground, but a lot of friends of mine that are also flint knappers have, and there's a lot of just historic records, especially from like Europe. There was a lot of care taken to secure or to procure so-called green chert from under the ground, where it still contains a fair bit of water. It hasn't been subjected to the elements. It's not weathered, and it tends to flake better. The gunflint industry in England, they would actually extract these big blocks of flint, which what I would call chert, but flint, and they would bury it under soil and under pine boughs, and just to keep the moisture content in place before they could work with it. So it works better. Now there's a problem overall with our chert. When I say it works better, it doesn't mean that you can take a block and you're just going to systematically remove big pieces from it. Inherently, in all of our chert in Montana, it is tough to make even palm-sized flakes consistently because of all the internal fractures. So green or not, it probably flakes a little better, a little more consistently, but it's tough material to work. You don't just start with a block and just pop off big flakes as you like. I mean, you'll inevitably run into internal problems, and so it's tough material.
I have this poster, and back on the round table in the back are handouts. If you would like, if there are handouts of this poster, it's the same thing. If you want a projectile point chronology for basically the Northwestern Plains, that's it. And so there are a bunch of them back there.
You can see where Pelican Lake fits in.
How big are the nodules? Are they uniform? I mean, what was their goal as they were? What constituted good ore for them?
You know, and that's very subjective. I guess what I have seen is, depending on the person and what their intent was, they could use something so ridiculously small that I don't understand how they could even drive a flake off of it, to something that would probably be not quite the size of a large, well, maybe twice the size of a grapefruit. And we know at Schmitt, we've seen the casts in the wall where there was a chert nodule and it pulled out. So yeah, I'd say if you're looking to range, maybe fist size. The university or the Museum of the Rockies, the collection of cores that they've got. Now, granted, these have been reduced through percussion flaking. Somebody's taken a rock or an antler and popped off big flakes from as many as they could and then left the core behind. But the biggest core that I saw was approximately like that. Most are much smaller, like fist size. So it wasn't big pieces necessarily they were after. They were just after usable pieces for them.
Any indication that this material was heat treated, either at the site or at sites where material is shown up?
Please repeat the question, Patrick.
The question is, was any of the material heat treated? So that we know that if you take certain cherts, certain grainy pieces of material especially, and you subject them to certain temperatures, increasing that temperature to a certain point, they become a little more glassy and easier to work, easier to nap. And to answer Jim's question, I haven't looked at enough of the collection to know. Some of it is just naturally really glassy, and so it's hard to tell. You know, at the mine itself, there were no thermal features, and there was charcoal scattered throughout the fill, but there were no formal features, so it's hard to say if or where they were actually heat treating the material. And there's so much work that needs to be done, Jim, that on Schmitt, I hopefully someday it'll somebody will take it on, but yeah, I don't know.